talk about how to hijack a Kubernetes cluster and how easy it is. But before we start, my name is Nico Meisenzahl. I'm doing stuff around cloud native, Kubernetes, DevOps topics, and mainly focused on Azure. I'm Microsoft MVP, GitHub Hero, and doing stuff in the ecosystem. Just to give you some insights, ideas for this talk. So this is not really a in-depth security talk. So it's really more about making you aware of things you could maybe do better, or if you do not think about or have not thought about any container Kubernetes related stuff, to give you some hints what can happen and how you can prevent those things. So basically it's just about common best practices you will find on the internet, but just showing you some nice things you can do in a cluster if something's going wrong. We are mainly doing or starting with the hands-on part and doing a demo here. So I have 3 more slides, and everything I will do in the demo is already available on my GitHub. So you will find the slide there. You will find how to spin up your environment and all the things I'm doing in just a minute. So why do we need to care about security? This is a screenshot from Red Hat's State of Kubernetes report, which they published, I don't know, some month ago. So it's pretty new. And they're pretty nice questions, so it's why I dropped here. First one is basically, have you any security incidents or issues related to containers or Kubernetes? And basically, more than 50% said, hey, we detected misconfigurations. More than 38% said, hey, we had a security issue. We had a security issue even in runtime, so really deployed and running in your Kubernetes cluster, and also failed or missing audited was around about 22%. Also, they have asked if somebody or a company had a revenue or customer lose due to those security issues, and also here nearly 31% or more than 30% said, yeah, we had an issue here. So it looks like we still need to talk about the basic stuff of container and Kubernetes security. Otherwise, the numbers should be different. So what we'll do. So I will be the person on the left here, and basically we will inject into our running application, into our cluster, via Log4Shell. I will talk about Log4Shell in just a sec, and basically getting access into our pod running into our cluster. And from there, we will try to open up a reverse shell to our attacker machine. So basically, the attacker machine is just a Linux machine somewhere in the internet. And basically, from there, we then are able to execute commands within our pod, within our cluster. And then we're trying to talk to the Kubernetes API server, seeing if we have some access right there, seeing if we find some nice things. We are trying to hijack the node itself, so maybe seeing other workload running on the node. And from there, also trying to access data and other resources related to different workload. And last but not least, we also try to hijack other cloud resources running in the same instance of our cloud provider. So we will do this on Azure, but basically it will be the same with AWS, GCP, or you name it. Talking about Log4Shell, just some info there. So basically, I guess you all know it, but what is happening if you are doing Log4Shell? Basically, you have you will do an CNDI lookup. This string is basically logged by the log4j library, and basically we will inject an URL to an LDAP server, and then basically log4j will talk to this LDAP server, which we are hosting, and the LDAP server says, hey, please load a Java class from this web server, which we will also provide, and with this we will be able to basically inject the code and spin up a reverse shell. And with this reverse shell, we will then be able to talk or to execute commands in the whole pod. And starting with this, I will go over to the demo and let's see how the stuff works. I hope it's big enough. Otherwise, please give me a hint. I will open up just the markdown up front. You will find it on GitHub. It's completely the same one. Below in my command line, I'm also SSH'd into our attacker machine, just a Linux, an Ubuntu in this case, which we will use to spin up the LDAP server, to spin up the HTTP server, and then also get the reverse connection too. To do so, we have to do 2 things. First one is starting up the LDAP and HTTP server. This is basically an open source project which they did a POC with Log4Shell. It's also available on GitHub, so it's not my code, but we'll just use it to basically spin up the LDAP and the HTTP server to be able to inject. And then for the reverse shell, we will also just use netcat here and open up a port. I've chosen 443 here, just might be a port that is open for outboarding connection on the pod. We could use any port here. Yeah, and then we have our application here. Just making this one a little bit bigger. It's just a login screen. It's part of the POC application. And here we will basically inject our source code. So we will go here for GNDI LDAP, putting in the IP address of our attacker host and the LDAP port. And here, basically just putting any password, doesn't matter, and pressing the login button. Now it's loading, loading, loading. Nothing happens. But if we now go back to our terminal, you will see there's a connection received. And if we now do, for example, an ls here, we get some files. So basically, we now have an open reverse shell in our pod. We're seeing some folders here, some source code here, so we are now able to execute any kind of commands within our running pod instance. Yeah, from there we will go ahead and try to talk to the API server of Kubernetes, which is pretty easy. So basically, we need a certificate and we need a token. Both is by default at the moment injected in our pod. So basically, just grabbing the token and the certificate here, putting into environment variables, and then we can use curl. I will copy paste them, and then we'll show you what I'm doing here. Doing a curl, providing the certificate, providing a header with the bearer token. It's basically the token we just exposed in our environment variables, and doing get here. And also for the URL, we don't need to know anything. Those are default environment variables which get injected out of the box by Kubernetes. And just saying, okay, would like to talk to the Kubernetes API server /API, and executing that one. And we're getting something back, which is good. So it's no error. Looks like we have somehow access to our API server, which is bad. So we have now 2 options. Option 1 is the application we connected to somehow needs to talk to the API server, need those access rights. Or on the other hand, basically we're having a service account in Kubernetes which somehow has access but doesn't need it. Maybe somebody deployed a YAML file, copied it over from Google, or it's a leftover or something. But anyway, for us it's nice. We can now use those access rights and see if we can do something else. So next one, we just now talk to the API server. So let's see if we can get access to the pods running in our namespace. So far we don't know our namespace. So first thing we'll do, basically get the name of our namespace, which is also exposed in a file in our pod, putting that one into the environment variable here, and then basically doing a pretty similar curl. It's basically the same, just here at the end, we're adding /API/v1 namespace, put in our namespace, and then we say, okay, now we would like to get to see our pods. Executing that one, and once again, we do not get an error here, so we're seeing some data. So it looks like we are able to at least see workload in our current namespace. So it's pretty ugly. So why not? We know we were able to spin up a reverse shell. So we have internet access. We open it up in 443. So basically we can do anything. So first thing, let's just download kubectl here to make our life easier. Guess this will take some seconds. Okay, let's try. And now doing a kubectl get pods. And you will see we have a pod running here. So basically also kubectl have any single place which it needs to authenticate and connect to the API server. So we are really able to see our namespace. Currently, we are the only pod running there. So let's do it with a -A to see all namespaces and all pods, and see if this will work. Okay, here we're getting forbidden, but now we at least see, hey, we are the default service account in the default namespace, so it really look like we just have access because there's a leftover, a role binding leftover something, so we shouldn't be able to get access to the API server, but hey, here's here. So now let's try if we can do a kubectl get nodes here to see the nodes in our cluster. Okay, also that one is denied, so it really looks like we only have access to the default namespace. Then there's a pretty nice feature. You can use kubectl to ask the API server if you are allowed to do something. So basically we're now asking if we are allowed to create a pod in our current namespace. Let's see what we'll get. We're getting a yes. So it looks like we not only have read access, we only have write access. And this is pretty nice, at least for us. For the person who owns the cluster, it's not really nice. But for us, it's really nice. So the next thing we will try is to get access to the node. So far, we're seeing one namespace, we're seeing one pod. But on the node, I'm pretty sure there's way more workload we just do not see. And if we have access to the node, we can just access those workloads too. So for this, we will spin up a pod. And the pod will have two things, or let's say three things. We will first of all use Ubuntu latest, just because, hey, there are many tools in there. We do not need to install all the stuff. And we will try to mount something here. And what we will mount will be a host path. So we'll try to mount the daemon of ContainerD. So if we are able to do so, we basically have the daemon mounted in our pod, and then can basically talk to the ContainerD instance running on the node. And to have an easier life later, we also try to run it with privileged access rights to have even more options to talk to the node later. But we do not use it at the moment. So let's see if we're able to mount the host file system here. Looks good. So it looks like there are no policies or anything in the cluster, so we can just mount that one here. And so now doing a kubectl exec into the cluster, into the pod we just created, doing another ls. So this is now the Ubuntu machine. To get a little bit easier life, we're just installing curl and jQuery. We'll just take a second, hopefully. And because we were able to mount the ContainerD daemon into our pod, we're also downloading CLI for that one here. And because we have access to the internet, it's pretty easy. Otherwise, we now would have to talk to curl, to the API, and so on. But just having the CLI is a way more easier. Yeah, and next thing would be we're using the ContainerD CLI here. We need to provide an address for the socket because it's not the default location, because we mounted it to mount. We're saying, okay, we only want to see anything which is the namebase cat.sio, and we would like to do a container list here. And then, if this works, we should see all workload, all pods and containers running on the node. And as you see, from the Kubernetes side, we just saw one pod. Now, from the host side, we basically see way more pods, so everything running on the node. And with this, we can now see if we maybe find some credentials, if we maybe find some data or anything else which is not related to the pod we injected in, but to any other pod running on the same machine in the cluster. Yeah, so to do so, I just prepared something, so we'll just grab one specific container here. Can echo the ID here that it works, so basically it's one of the containers here. And in this container, we will also use the ContainerD CLI, providing the address once again, the namespace once again, and instead of container list, we're doing a container info, providing the ID, and then using jQuery to just pick some parts. And what is interesting for a workload, the environment variables injected into the runtime. So we're doing a spec process env here to get all the environment details. Here we have them, and we have them for a container running on the node. We do not see via Kubernetes. We have some path information, hostname information, the Kubernetes part. But hey, we also get a Redis key and a Redis host here. So it looks like it's a managed instance here on Azure. We have a key, so hey, why not accessing data from a completely different workload? Once again, we have internet access, so we make our life easier. Just installing the Redis tools here. And then we will grab the Redis host and the Redis key again from just the location we just saw to expose it. And then we can try to talk to the Redis, which is not linked anyway to our application we started with, but any Redis which might be available in the network of the cluster here. So let's see. We're doing a Redis CLI, providing the host name, providing the Redis key, and doing a get data here. And let's see. Okay, we're getting a warning because we shouldn't provide the password here on the command line, and here we're seeing some secret data. So we were able to talk to a Redis. We don't know before. We can now maybe also update the data, delete the data, dump the data, and I don't know, sell them afterwards, doesn't matter. But it's really bad. We were able to get access to data from a completely different application just by getting access through any kind of security issue. But let's do a little bit more. We're still located in our Kubernetes cluster. Yeah, we were able to talk to resources outside, to get access, to get some data information, yes. But hey, let's get even further. And in this case, this is basically an Azure Kubernetes service, so the managed offering on Azure. But basically, the thing we are now doing is a little bit Azure specific, but it also works on all other cloud providers. Just it's a little bit different. So next thing is we will try is to get from the Kubernetes cluster itself to get credentials and authentication to Azure itself, to then basically talk to Azure, provision resources, get access from Azure and stuff like this. So we're leaving Kubernetes and really going on the Azure side here. And Azure is just the cloud provider I'm using, so it works with all the others too. So first of all, we need to mount, create a temporary directory, and then we just mount the first disk we will find on the node. And this is where we have the privileged access of the pod we just created. We'll need this for this command here. And now we basically were able to mount the whole file system of the host. So it's not just one directory. We now have the full directory of the disk of the underlying node. And here we have some nice files. And there's an etc Kubernetes Azure JSON, which holds some Azure-related configuration for this cluster. And there we will find an ID, the so-called user-assigned identity ID, doesn't matter. It's basically just the identity of the cluster itself. So we're grabbing that one because we need it later. And of course, now we need a token or a password and so on. And this is pretty secure so far. There's an implementation where there's also the password in the file in clear text. But in our case, we can now use this identity and talk to Azure to get a one-time token we then can use. So basically, we do once again a longer command here. We're once again doing a curl here, then we're talking to this IP address. This is the so-called metadata service of Azure. It's the same with GCP and AWS, providing our identity and providing some further stuff, but basically we're telling Azure, hey, this is our identity, please give us a secret. And putting that one into this environment variable. And I can't show you that one because otherwise you could access my environment here. But we also need to create some further metadata information, Azure-related subscription and resource group, which is also stored in the Azure JSON file. And now we basically have all the details to talk to the Azure Resource Manager and authenticate with Azure to list data, to create data, or something else. So to do so, we're doing a get. Once again, providing our token here as bearer token, as header, setting the context type, and saying, hey, we would like to see in our subscription, in our resource group, all the Azure resources you find there. And if this now works, and it did, we basically authenticated with Azure, are able to get data, and in our case, we're also able to create data or create resources. So we could also go even further, and instead of doing the get, like we did, doing a put, and basically tell Azure, hey, we would like to get a storage account, we would like to get a virtual machine with GPU, mine some Bitcoins, I don't know. Basically just creating resources in Azure. So it takes some seconds here. In this case, it's a storage account, so basically just blob storage. And we just created this resource in Azure. And now we could get the data, access data from that one, and then store any kind of data in there or retrieve any kind of data. So basically, we're not talking about Kubernetes here. We're really in the underlying cloud provider and getting data from there. So basically, this is what can happen if you really do not think about any security and maybe copy-paste some YAML files from Google you found. Yes, it's a happy path, but we see it a lot at new customer projects that basically we have clusters and nobody cares about any kind of security. So what are the options to get it even better? Basically things you should talk about is secure application code, secure deployment codes, so secure YAMLs, building secure container images, thinking about Kubernetes policies, Kubernetes network policies, and also thinking about the runtime. So not thinking about, okay, I have a secure image, but also thinking about, okay, is the image still secure, I don't know, 2 weeks after you deployed it into your Kubernetes cluster, and so on, and many, many more. Which is also pretty important is to really try to start with smaller things. If you do not have anything in place, start really with the best practices, with the basics. So it doesn't help defining a security project, talking about security for, I don't know, 2 years. And after 2 years, you have a big list of things you would like to do, but you still do not have implemented anything in the cluster. So really start small, iterate, and get better and better over time. Yeah, so if some minutes left, so maybe a little bit faster, ensuring secure code means really check your code, use static code analysis, use the static code analysis and shift it left. So basically really scan your code when you're doing a pull request, when you're implementing the code, to really be sure that the code is secured and they basically implemented all the best practices here. Also scan your dependency, for example, with the Dependabot or Renovoid or anything like this, to really stay up to date with your dependencies, to see if there's an issue, to update it, and to really be secure. Also on the container image side, in some build secure and small container images. What does it mean? If you have less dependencies in your container image, it's smaller, and less dependency basically means you have less tools which might have any security issues. So think about self-contained binaries or distroless container images, or at least a small Linux distro like Alpine or anything to get rid of all the many dependencies you don't need when running your applications. Also enforce static code analysis for your Docker files to make sure that your Docker files are safe, and scan them all the time. Scan them when you build them, but also scan them afterwards to make sure that you might get any kind of new security issues which weren't released when you built the image itself. Yeah, with that, basically, it would be much harder for us to inject into the container because without this, we do not have any of the tooling in the pod. Maybe do not have Log4Shell in the pod, so it would make it much harder to hijack the cluster. If you would have scanned the container image, we would have seen that we still have Log4Shell in the container and it's not patched and not secure. And without Log4Shell, basically, this whole thing wouldn't work at all in our example. Yeah, also, not only about source code and your Docker files, also make sure that the deployment files on deployment code is secure and following best practices. So think about also a static code analysis for those to make sure that you have all the good best practices in your deployment YAML files and your pod configuration and so on. So think about not running the container as root, not monitoring any host paths and stuff like this. And also here, if you would have something in place which would have secured or validated the deployment of the pod we injected into, maybe also we have found out that this container has root access, which also helped us to get access to the node afterwards. Yeah, some tooling here to get you started for source code analysis, for the Kubernetes manifest, for Dockerfile, and also, for example, here Terraform or other infrastructure as code tools to validate that those code is secure here. The links are in the slides, and the slides are online, so you will find them afterwards. Talking about Kubernetes policies, also an important topic. There were also some talks today talking about here. So it's really important to define guardrails in your cluster to make sure that the users are not deploying anything here. So think about maybe enforcing read-only file systems, denying host path mounts, which we did to get access to the identity of the node, denying container which are running with the root user, and all the other things. So would we have some at least basic policies in place, which you can basically copy-paste from different locations and best practices sites, we basically would have had a much harder way to get access to the data and the resources and even Azure here. So really, really important topic. Yeah, talking about tooling here. With Kubernetes 1.25, we now have pod security admission, stable, so the successor of pod security policy is one option to get started. We have open policy agent gatekeeper, OPA, which you can use to implement policies if you like to, or also a Caverno, which also can help you implementing policies here. Yeah, another policies, network policies. Also really important here to really make sure which workload in the cluster is able to talk to another pod, or also which pods in your cluster are able to talk to an other application or data source. So think about why was our pod we injected into able to talk to the internet to spin up a reverse shell. Why was our pod able to talk to a Redis, which has nothing to do with our application itself? So why weren't there any network policies and network definitions which pod is allowed or which application is allowed to talk with any kind of dependencies? So really limit access to internet, limit access between application namespaces and their dependencies, and even further limit access to the cloud provider metadata service. So basically the curl, the IP we talk to get a one-time token for the identity of the cluster itself. Nobody needs this one. So basically also just the user of a cluster in your company can basically just get a token and get higher access than they would have if they access with their own user, for example. Also really, really important topic here. Once again, if we would have this network connections to the reverse shell, Redis, metadata service, and so on, would have been denied. And with it, basically, we wouldn't be able to open up a reverse shell at all. Yeah, and even further, if we're talking about runtime, also make sure that you maybe detect any threats and uncommon workloads in your pods. So think about, we basically connected to a pod, spin up a reverse shell, executed commands. So basically there are tools which can help you to really get informed, get alerted when this happens in your cluster. When they find untrusted processes, when there's shell running in a container, when a sensitive path like host path gets mounted in a pod in your cluster, when something in a pod makes a connection somewhere else, for example, to the metadata service. You get an alert and you can decide and maybe, do something, investigate, and so on. And here we also have nice tools. We have Falco, we have Tetragon, which can really help you to gain the insights into your running applications here. Yeah, with this, basically, also all of our work within the containers and pods would have been audited or alerted, and somebody could check and validate what's going on in the cluster here. Yeah, some smaller further best practices. Think about when to share a service account and when not to share a service account. Also, really think about if a service account needs access to talk to the Kubernetes API server. If the service account token really needs to be mounted, this changes or changed with Kubernetes 1.24 anyway. Then think about some seconds. Think about just copy some snippets from Google into your cluster and then ending up having role bindings you are not aware of. And also implementing a web application firewall is a nice idea to do so. One last thing, if you would like to get some further information, my colleague Phil and I will be joining the post-conference meetup tomorrow evening, so feel free to join that one to see some further security-related topics. And with this, I'm finished.
Come to your other side. We definitely have some questions. Let's see if we can get them up there. In case you haven't, please pull out your phones if you want to ask questions and or vote for the questions you think are most interesting. Okay, we can see everything now. First question. The attack surface of this could maybe be constrained by providing an allow list of container images for the cluster. Are there tools that recommend for this?
Yeah, basically the tool list I just shared before. Yeah, okay, we do not see it again. I think there are multiple tools which can help with that one. Now the question is gone, no? Okay, so maybe talking later about that one, but I think there should be tools available.
You can see the question here. I archived it so that we can go to the next question in a minute.
Maybe providing a low list of container image. Yeah, also good one. So basically policies telling which images are allowed to pull or to execute in the cluster. Yeah.
Next questions. Is there a Docker file?
So
what are you doing?
Okay, so maybe going for what is the life cycle of the bearer token you use? Does it expire? It will expire. I'm not 100% sure. I think it's either 30 minutes or 1 hour, but it really depends on the cloud provider. But also you have access to Azure, so even if your token only lives for 30 minutes are enough to create another identity, which you then can use again to exit it. Yeah, so it doesn't matter. It's enough to create resources to get access to. But this is possible in case of a private cluster. Some parts of it. So if you are, let's say the application was exposed to the internet, we could have done the reverse shell thingy, for example. And basically then we can talk to the API server, we can talk to, for example, the Redis, to the metadata service. So some parts would be possible, of course, yeah.
Okay. Is there a Docker file SAST scanner that scans more than the base image?
I think there are many. So basically scanning the base image, also scanning the source code running or being installed, or libraries being installed in the container image. So for example, Trivy or anything, they're scanning more than just the base image.
Okay, last question, because we're heading to the end of our time.
There's one hard-coded IP at the beginning of the Azure part. Yeah, so this IP address is basically the metadata service of Azure. So this is the IP everyone can use, and a well-documented IP for Azure, and I think it's the same one for AWS and Google. So you just need to search for it and can use it. So it's basically hard-coded.
Okay, we have only one question left, so let's do that for the end.
As Kubernetes becomes more and more popular, do you see a growing number of attacks and vulnerabilities? To be honest, I only have the statistics I shared with you. So in our project and customers, we never had a customer which had an issue. But basically, this is also why I started with this talk. We have seen many environments and many new customers, projects, which basically do not think about it. So I think, yeah, there are many people who have issues because many people are not thinking about security at all.
You can talk very quick.
We do not have any time.
Close to my word count. God damn. Thank you so much for being here. You also get your card deck.
Thank you.
So that you can enjoy your game. Thank you, Nico.
Thanks everyone for joining.